Okay, hello everyone. Uh, have you decided yet when will be the quiz? Is it next week or next 2 weeks? Huh? 2 weeks? But after next week, I mean after 2 weeks, the next week will be final, is it? Do you prefer that or early quiz? Okay. So I think maybe next week, right?
Next week we have chemistry again.
Yeah, but if we do next 2 weeks, like
Okay.
the next after that is final exam. Like if it maybe take only 1 week between the quiz and the final exam. Do you prefer that?
We'll review, right?
Yeah, if we have time like early quiz, we have time for review.
Okay.
I think that's okay. So let me write here that the quiz will be 12/7. Topics are chapter 5, chapter 6. Chapter 5 means the introduction of integral, the substitution method, the fundamental theorem of calculus. Okay. And then chapter 6 includes the area between curves and volume. And since I think I will finish all chapter 6 by today, and maybe some introductory to chapter 7. And since next Tuesday, there will be no class, but you will have like 2-hour TA class. So you will have more practices and more examples from TA. And then that is, I believe, for quiz preparations, okay? Quiz preparation. So Thursday, 7th of December will be quiz. And then we are expecting to have final exam on 21. Okay. 21 final exam. Okay. So I need to get into the next chapter by today, at least introductory techniques. Okay. So let me a little bit do some review. So last time we have this, right? So we are curious how we can find the volume if we rotate this to here. Okay. Since if we think on the XR, XL, or the top and bottom, both of them are on the same curve, right? Same function, which means we need to try another method, which we call the cylindrical shell. So basically, we are trying to make this, and we see that when we rotate, we are going to have somehow. Actually, this is from this side. So if we rotate this rectangle, this red rectangle, we are getting this profile, okay? Like a can of soda, right? Like a can. So it's hollow, okay? And to find this volume, basically we need to have the thickness, right? And then multiply the surface area. Okay? Or to make it simple, we can cut this. Okay? Cut the can and then stretch out. And you can see that we have this, right? We have this. We have this. So we are somehow approaching this profile with this rectangular shape, which we can think that okay, the height and the base, okay, just multiply all of them, right? And that's why we have this approach. Okay? Alongside with some of our intuitive proof using the radius, okay, in the can. Okay? So we let the delta r as the difference between the outer radius and the inner radius, and then we have the average radius between the R2 and R1. Okay, and then we have this. Okay? Now the question is how to apply this practically in our problem. So basically, let's move to the next one. So this is where if we take one profile and then we add all those profile all together using the sum, and somehow we take the limit as n getting approached to infinity, then it will equal to our definition of integral. Okay? So using the same exact formula from the previous models, we can get the integration from a to b 2 pi x f of x dx. Okay? And it works for dy as well, as long as we can get the same cylindrical shell profile. And this is if we have in terms of variable x. Okay? So then we can try to look at this. Okay? If we rotate this, actually this is example, the fifth example that I would like to show you, that we can choose which method we are going to use. Okay, so we can choose this as, I think if you rotate through this line, we can use the first method that we usually use, the disk method, and you will get the circle with the hollow. We can use that as well. Or we can take the so we can take this as our rectangle, and then imagine that this will be rotated here. Okay, right? So the idea is, let me rewrite this. Okay, so this x is actually the radius in terms of cylindrical shell. Okay. This is the height, and this will be the thickness, right? Now our case, the radius is this one, right? So if I say that this will be x, to get into the x equal -1, we need to x plus 1, right? You get it? Okay. So let me write here as the distance from this to here. So that is the radius. The radius is x plus 1. Okay. How do we get x? X is, we can imagine x is any number starting from this y-axis that's going to get into this side. Okay. It can be any number, right? We can set it here, set it here. Okay, so we say that this is x. Okay. And then this is a constant 1. So the total radius becomes x plus 1. So this is radius on the cylindrical shell. Okay, so I want you to differentiate between the cylindrical shell and the disk method as a different way to observe. Okay, so this is the radius, and the height will be this. Okay, the difference on x squared and 2x, or 2x minus x squared. That will be the height, right? So let's write over here. That's the height. So basically, we are using all this information, the radius, the height, and perfectly fitting with our shell method. Okay. So write all the things. So volume 2 pi. This will be x plus 1, and then
This will be 2x minus x squared, and then the x. Okay. And then we are going to evaluate. We are going to evaluate from 0 to this point. At this point, we need to find equivalent is both. This will be 2, right? I forgot to mention. So this will be 2. So our endpoint is from 0 to 2. And then we can multiply and then integrate, okay, each one of them. I will take out 2 pi outside, and this will be 2x squared plus 2x, right? And then minus x cubed minus x squared, right? So we have x squared plus 2x minus x cubed. And then we have 2 pi, integrate 1 by 1, x cubed over 3 plus x squared minus x with power of 4 from 0 to 2. This will be 8 over 3 plus 4 minus, this will be 16 over 4, so 4. So it will be 8 over 3. Multiply with 2 pi, we can become 16 over 3. Okay.
Now, however, this part, we can use the previous method as well. So you can choose. You can choose this way, using cylindrical, or using the disk method. If you're using the disk method, the way you see is we are going to use dy for this one, because it has like this and that, which we are going to see if we rotate that this is the top and this is the bottom. Okay.
So I think, let me copy the picture. So aside on the new method, the previous method also can be used. So let's say we have this one, okay, and we rotate on that. Okay. Remember, on the disk method, we focus on the area of the circle, right? Pi r squared. And if there is a hollow, it will be pi outer radius minus the inner radius, and it's squared, right? Maybe let me put this on, I think I will put it here so you can see both of them, right? So based on what we have in terms of our functions, now we are going to look the rectangle here, the blue one, using the dy. So this will be dy. So we are going to exchange all the function into function of y, which means this will be x equal half y, and this will be square root of y.
So now the radius is, now we have square root of y, okay, as the functions.
So let me write that the a that we have, ay, this is pi. Let me write outer radius squared minus, or maybe let me write on this side here, minus the inner radius squared, okay? So this will be pi, the outer radius become the square root of y plus 1, right? Squared minus the half y plus 1 squared. Okay. And then taking the volume, integration of this pi, and put everything half y plus 1 squared dy. Okay.
Okay. So basically this profile is like a disk. Okay? The area multiplied with the height, now the height is the dy. Okay? So I don't want to be like confusing between these two because they have the same terms. Like for example, we say this is height, but the height on this one is the dy itself. Okay? Now the dx here, we call the thickness. But I think as long as you can define the profile, no matter how the terms will be, as long as you know which one is which, I think should be okay. Right? As long as you can draw like, oh, we have this profile here, okay, then we can use this cylindrical shell. And actually you can choose, like if you want to make the disk one, then you can focus on the disk, which relate to this circle area, or the cylindrical shell, which the profile use the surface area multiplied with the height and thickness. Okay. So I think you can solve this, and oh, the end point is the y, right? The 0 until 2x, if this is 2 is 4, right? So 0 to 4. I forgot to
Right. So this is 0 to 4. So you can check, and then we can do some expansion before that. So we will have, so cancel and cancel. We have volume is 2 squared of y minus 1 over 4 y squared dy. And finally, we can integrate all of this. Square root of y is 3 over 2. So 2 over 3 multiplied by 2 is 4 over 3. And then minus, this will be 1 over 12. Okay, a little bit computations. I also don't like this computations. 4 is 2, 8, 8, 4, 32 over 3. Where is the pi? I forgot the pi. Okay, but since it's digital, I can edit. If you use the paper, then especially in the exam, it's it's trouble, right? Okay, pi is in the front here. Okay, so this will be pi. So I forgot what is the number here? 4, 8, 32 over 3, and this will be what? 4, 16, right? 16 over 3. Yeah. Okay. So this is the same. So 16 over 3. Okay. Okay.
Sometimes the left will be easier, sometimes the right will be easier. Depends. It depends on the case. It depends on the case. But most of the case, you can use the cylindrical shell for every for every occasion. But if you look on like how much like the difficulty, the easiest one that can be profiled for me personally is this method. Easy to see from the disk, easy to imagine in our mind. Like, oh, you can have this, a circle. Sometimes this we need to like really draw. Okay? Like if you want to just use your mind to compute, I think this method easier. But if you see the cylindrical shell, and you need to use cylindrical shell, my advice is draw. Well, actually draw both of this, but sometimes you are going to read the question first, like which method that is applicable, and then you can try like both cases. Okay.
So here's the picture actually for the this method, and so see the difference.
This is the profile for the cylindrical shell. Okay? We take this and then we rotate. But for the disk, we take this one. Okay. And for a function like
The previous page. Let me go here a little bit while.
if we rotate through here, the only way we can do this is through this cylindrical shell. Because the disk method will not work if this profile appears, if this kind of function. Like for example, if we have a functions like same thing with in function of y like that, and you need to rotate here. Also only cylindrical shell that applies. So you will see some obvious function that can be only applied by cylindrical shell, actually. If you know the pattern, like any kind of this, that when you deal with the finding which one is on the top, the function, and you see that there is only one function, that means you can only use the cylindrical shell. Okay.
So that's I think important. Okay, so to see the difference between these two. Okay, so I would like to give you some practice, but before the practice, I would like to give one more thing on still in this chapter 6, which we, so it's called the average value. Average value. So let me give you that first, and then maybe if we have time, we can have a little bit more practice and example. So average value, okay? So average value of a function. So if you're working in the Google Sheet or Excel, like you have like a data sets. Let's say you have A, B, or maybe the A, B is not here. Maybe will be A, B, C, D. Maybe this is the name. Maybe the unit, and then this is the price. 100, 200, maybe different price, and maybe this will be 350. Okay, and then usually we take if you want to take the average, we can write the functions as average, right? And then we put let's say this is the so in the Google Sheet we have so we have, let's say this is A, this is B, okay, and this is 1, 2, 3, 4, 5. So based on this we have. This is just illustration. So A2 until or B2 here. Sorry. B2 until B5, and then you type into your computer and you get the number, right? Well, basically, how this will be counted as an average is basically we add all of them and divide by 4. Right? As easy as that. So basically, if we have a function, and we would like to know the average of that function. So every data set that we have, like from y1 plus y2 until like how many we have, like yn, we divide by the number of the n itself, okay? Now, if we remember, in the definition of integral, if we have like a random function like that, and we would like to know, like if we cut this like from A to B, and we have the profile of the rectangle, the small rectangle that we cut, and let's say this is the delta x. Our delta x is basically the difference between B and A divided by how many rectangle we have, how many we cut, right? Okay. Now we could somehow switch this and write as n is basically B minus A over delta x. Okay. Now let's use this n to change this. Okay. So our y average then becomes, let's write y as a function of x. So function of x1, that's a sample point, divide with n, and I will change the n into b minus a over delta x. And then we simplify the algebra, so we get the average is 1 over b minus a, and then we have this whole summation of f. Oh, let me move a little bit, maybe make it smaller here, the size for one. So xn, and then the delta x can be written here. And then you see that we could somehow see all these functions as a summation, right? As if you remember how we approached the integral using this with summation and then take the limit, and it's become our integration, right? So we can write this as summation of from I equal 1 until some n of our xi sample point delta x. And then we know that this is by definition of limit, so as n getting larger and larger, then our average becomes 1 over b minus a integration a b f of x dx. Okay. So it's not really like complicated or complex. It's pretty much like you can imagine like how we can find the average value from a table of a function. Like if you are dealing with the Excel or Google Sheet, I believe this will be very practical, and we can really get into the data set really I think quite simple. So this is, we call the average value of a function. Okay. And of course, if we are trying to say that this y average as also our function, so there will be a point that is going to be exactly at this average. So we have average value, and we can think like, what will be the average value at what x, right? So we can have the mean value theorem that says that the average value, like in the between of the interval, will be there will be exist at least one point, okay? That there will be the average value. So we can write the mean value theorem for integrals. It's actually quite simple. Like you have a function like this, okay? And you know the average value of this function, that is basically area under the curve divided by the interval, right? The distance b minus a. And you know how much is it? And it will equal, or there will be a point that when we plug in into the function, there will be in between this a, b. So this should be called the point C. Okay. So there will be exist point C on the interval a, b, that the f of c is equal to f average, which is the whole function that we did here. And we can rewrite this as integration. Maybe let me make it bigger. So integration from a to b, f of x dx equal f of c b minus a. Just move here so you can write like that. And that is the whole chapter 6. I skipped I think the middle part. Do we have the middle part? Oh yeah, I skipped the work, okay? So 6.4, if you have the textbook, we skip that, okay? Because I think that is more in line with physics, although we can also deal with that, but I don't think we have much time for covering all of the sections, so we skip that, and we can focus more on the calculus part. Okay, maybe also this week, to help you to practice, I think I can prepare some questions that you can follow. Also, if I have time, I will prepare some solution of some representative questions. Okay. Okay, because I think practically we only have around 3 weeks, normally 3 weeks. And since next week, quiz. But before quiz, we have a class first, or 1 hour, okay? 1 hour class and then 1 hour quiz. So, yeah. Yeah, I think we can arrange later. Because if you have a class, you will not be focused. We worry about what kind of question that might appear in the quiz. Okay, so we have 3 weeks. So we have next week quiz and maybe a class. And next 2 weeks is focus on chapter 7. I think chapter 7, since it's a lot, maybe I will prepare videos recording another additional part, and also additional classes that I will confirm which one. Okay, we will have just one more class, okay, in Saturday. Only one. Only one. Okay.
Sir,
Yes?
This Saturday or the Saturday after?
Not this Saturday. Maybe next. Okay. Next or next 2 weeks. Okay. I will confirm later.
Okay.
But this week will be maybe basic of math. Maybe. I'm still confirming about that. Because I worry about your mathematics. Okay. Okay. Okay, I think we can go for some introduction for the techniques of integration. Okay. Techniques of integration. So we start with the one we call the Integration by parts. Okay. 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 So we need to move on. Okay. Pretty quick. I'm sorry about the pace, but later I want to make sure that we can have review for all. Okay. Okay. Now I would like to start with not like a mathematical proof or something like that, but just intuitive proof that we can use practically as in our daily life. Okay. So if you know the derivatives, and I will also let me write the function f, the capital F, in terms of the multiplication of the small f and small g. Okay, let's say we have this, and then this function I will derive all of them. Okay, so we are going to have dx, and basically this is a product rule, right? So we have f prime g plus g prime f. Okay, now I will exchange this f into the fg as our definition. Okay, so we can rewrite this in more clean way. F prime means that d dx multiply with f and then multiply with g, right? And g prime is d dx of g multiply with f. Okay, now if we have integration on all terms, okay, with respect to dx, okay, now this will be canceling the derivative on the front. Okay, so this will be f g, this will be integration. Let me write g first, and then d dx for f let me write as df. Okay, and then plus this is f dg, and we can arrange this as I will put the f dg on the left and then we multiply with negative, so it will be positive, and this will be f g, and then it will be minus g df, and practically this is integration by parts. Okay, this structure. Okay, now let me get into the definition for each one of them. So let u is function of x, so du is f prime x dx, okay, in terms of differential, and let v as g of x, and dv is g prime x dx. By doing so, we can rewrite this structure. So let me write as f of x, and then this is g prime x dx, and then this is f of x. Basically the same thing, but I will write more complete. This will be g of x, and then f prime x dx. Maybe let me make it more clear. This will be dx. Okay. So we can write this as u g prime is d phi. This will be u phi minus phi du. The one that I think familiar with you, right? So what's the deal and what's the point of all of this? So basically, if you read the integration, if you can define the structure, which one is u, which one is d phi,
And then from this u and dp, from u we can derive finding du. From dp we can integrate and finding v. And then we can plug in into the rest of the equation. For example,
if we have like a simple integration of ln x dx, okay?
can we integrate this? So if we think like using any method that we had before, maybe not really that intuitive. Maybe we can try several times using like guessing method, but I don't think that would be a good approach. But if you think that ln x we can derive easily, and dx, we can think dx, and if we integrate, we can have x, right? If we integrate dx, it will be x, right? So I think we can use this as our method to solve.
So basically, we take u is ln x, du become 1 over x, and dv is dx, so v is x. So we can apply this
And then filling in this structure, okay?
So we can write that the ln x dx is equal x ln x minus, and then v is x, du is 1 over x, and then dx. So this will be cancelled, and we have x ln x minus x plus c.
And then if we check, if we derive this as ln x, this will be ln x plus x.
Let me just write here just to make sure that. So ddx of x ln x minus x. So this will be ln x plus wait. Oh, this will be 1. Why I'm writing x, but that's why I'm confusing why it's
Doesn't cancel. Okay, this will be cancelled, and this will be back to the our original equation. Okay, that had me worried for a second. Okay, that's how we deal with the integration by parts in the simple equation. I'll get into more practical way how to take this integration by parts to the next level, which requires some identification on the function itself. Okay. So I think to master or to skillfully master the integrations, first you need to have like a good understanding of derivatives, and the second, good observations of a function, which means that you need to have at least trial and error for the functions when you try to integrate one by one. Let's try some example and see how we can take that as a way for observe the function itself. Okay. So let's say we have integration of x sine x dx. And then compare with the other one is x squared sine 3x. I will start some function that is pretty similar, and we would like to see how these two will be related and how we can identify the functions in the future. Oh, sorry. Which one? Okay. subtract this one. Basically, you can derive by yourself, taking the capital F, derive, and then integrate. Derive and integrate.
So what is the product of x ln x minus x?
Oh, this one?
The minus x, where do you get that x?
Which is x?
Yeah.
From here. Integration of x, 1 over x is equal to 1, dx.
Oh, one. Oh, it's
Yeah, cancel.
Cancel. This one is cancel. Okay. Well, anyway,
As long as you can identify this part, the structure, which one is u, which one is dv, the one you take as u, you need to derive, becomes du. The one you have dv, you integrate, becomes v. Okay.
so let's take that and use it in this example. Okay, we have two examples. The first one is, I think, simple. Again, it's very simple. We can take u as x, and du will be dx, right? And then dv, we can take sine x. And v is negative cosine x. And sometimes you can check both of possibility, because we can have like both, right? But
You need to understand, like if we take the x as d, like dv, then we need to integrate and become half x squared. You will see that if we set up that information and we expect to integrate, if it doesn't make the equation simpler, then maybe we need to try another one. Okay? So at the very beginning, you need to do some check, okay? Trial and error. Which one is u, which one is dv? Okay? If you are making mistake at the beginning, and maybe that it will be very long, and the integration seems not like if you make a mistake, the loop of the integration, like you get integral, and the other integral need to have by parts again, and they will be looping all the way around it. So it's not having any solution. Okay, we have a break for a while.
then we will have a class, not this Saturday, next week Saturday. So hopefully we can have like more exercise this this 9 December. Same class, but from 9 to 11. Okay. Hopefully it can be your motivation. Maybe you can have exercise more. Okay. Anyway, let's go back to here. Okay. I think very simple, right? So we just put all the information into our structure. So this will be uv, this will be negative x cosine x, and then we have negative of the negative cosine x dx, right? Or we have negative x cosine x. This will be plus cosine x dx, and this integration will become plus sine x and then plus c. Yeah, very easy, right? Now let's improve the question and make it a little bit complicated.
And let's say we have x squared, and then we have sine 3x. And let's try.
Okay, let's try. And after some time, I will give you some tips how to solve the integration by parts with a very simple. I feel that it is a very simple method. Using the same integration by parts, but the difference is I will tell you how to make up the equation into simple process. So the idea of integration by parts is in the integration itself, we need to think which part that can be integrated and which part that can be derived. One mistake that usually happens is if you choose the wrong components. Okay? If you choose, for example, the first one here. Okay? If you choose u is sine x, and then the dv is x dx. Okay? If you choose that, the x become
1 over 2x squared. And sine x, it becomes a cosine x. And you can also think, like if you see trigonometry, like sine or cosine, it always cycle, right? It always have a loop. Either you integrate or you derive. Sine, cosine, and you can just add negative, plus, right? But this one, x, if you integrate, it also cannot end, right? It will be x squared, x cubed, x4 if you integrate again and again. But if you do reverse that, if you derive x, somehow it will be 0, right? And that's how you choose why it's become your u. You understand? You get it? Get it? So let me explain again. Okay? You have x, you have sine x. You can think like if you integrate x, it will not end. You can integrate again and again and again repeatedly, right? If you derive sine, also a cycle. While for sine or cosine, both of them, if you derive, if you integrate, they are going to be the same. They have cycles, right? Sine, cosine, sine, cosine. But for x, if you derive, it will stop at 0. Agree? Right? Agree? Do you agree? That's how you choose. Okay? That's how you choose. That is your u. Okay. Now the same thing with this part here. How you choose is basically you see that we have x squared and we have another sign. No matter how complicated it is, it's still a trigonometry that we still have cycles. Sine become cosine, sine, cosine, right? Always cycles. And x squared, if you derive, somehow it will reach 0. So we choose this x squared as our u. Okay?
That's how we deal with that. I will not yet arrive at how I will use this method, okay? But let me just write using the method that I gave you earlier, okay? So this will be u and this will be dv, okay? So u x squared du become 2x dx. dv is sine 3x dx if you want to add dx, and the v is negative cosine 3x over 3. So then we can take that into our new formulation here. So this is uv, okay? So let me write here, this is uv. And then we have v du. So we have minus, v is here, negative. So since it's negative, negative become plus, okay? And I will write 2 over 3 outside. This is from 2x and 1 over 3. So this is become x cosine 3x dx. Okay.
Now this part is another integration by parts. So
It has another integration by parts. You can choose different variable, but I will just use u and v because it's familiar and we know. So we can take this and then take the dv. And again, here is we have, let me just write plus 2 over 3, and then the inside will be x sine 3x over 3 minus, at the end we have only sine. Now finally, the last part become cosine 3x over 9, and this will be negative, right? So negative, negative, positive, so it's become plus. So we are writing everything here. So integration x squared sine 3x dx is negative x squared cosine 3x over 3, and then 2 over 3 I will multiply 1 by 1, 2 over 9 x sine 3x, and then 2 over 3 multiplied with 1 over 9, it will be 2 over 27 cosine 3x plus c. Okay, that's the answer. Now, if you think, like, what's happening if I choose, like, if we have x cubed or x to the power of 4, we will have some multiple integration by part inside of it. Right? Integration by part, inside integration by part, inside integration by part, and then we do this cycle. Okay? Now, is there any way to simplify the method? Okay, now let me give you this simple way. Okay. Yeah, let me tell you. Okay. So, based on what we have something that needs to be derived. Let me write as d. Okay, and we need to have something that we need to integrate from the equation, right? So we have the integration. So we choose the d is x squared, and for the integration is sine 3x. Exactly the same reason that if we derive this, it will reach 0, right? So then we derive, this part we derive until 0. And then the other part we integrate. So this will be negative cosine 3x over 3. Let me give space. And then again, integrate one more. This will be negative sine 3x. Now multiply by 3 by 3, so 9. And then again, integration. It's negative is called positive cosine 3x. And then 9 with 3 is 27. And then you see that our structure on this UDV is always UV minus, right? It's always plus minus. And then you have another integration by part inside, you have plus minus. You have another integration, you have plus minus. Okay? So we need to multiply all with plus minus, plus minus. So let me add that into here, plus minus, plus minus. Okay. And what you need to do is multiply this with this. Okay. So multiply, and then we can arrange all this structure nicely. So it seems like a shortcut, but actually this is the same formula for integration by part, and I will show you how. This will be negative x squared cosine 3x over 3, and then that will be plus 2 over 9 x sine 3x, and perfectly the same, plus 2 over 27 cosine 3x, and don't forget to add plus constant. Same. So how this can be like really works? Okay. So actually this is using the table. Okay. So if you take the table, so let's say this is the d, this is I, and this is actually, we take u and dv, right? And dv, du, derive du, and this become v. This is a nice arrangement of our method. So actually, if this not zero, the very end, we need to multiply this and write at the very end, still in the integration. So if we have like this one here, so we still have like not a zero number here. Well, if we multiply 0, like it's gone there. But if we have like du here, then this is actually a nice way to write our integration by part. Okay. But we simplified because we will have sometimes when we integrate this will be another integration by part. And the next part may be another integration by part. So those cycles we can simplify into the table. Okay? And then we can just take the I, and then this will be derived, this will be integration, and this whole thing will be plus minus plus minus.
But I'm not recommend this if you take maybe another class with another professor. You give this and maybe he will. But in my class, you can try this, okay? Because this is actually the same thing as this. Okay? Most of the time, it will work. The only way that maybe it will be a little bit difficult is if you are not able to find the zero here. Okay? That you need to, for example, you still have some component that still has the integration that you need to solve, okay, at the end.
Yes?
Zoom out.
Here? So there are some cases
That maybe it's not exactly zero here. Maybe still have some elements. Or, for some cases, you will get like repeated loops, and then we will not like it will not end. But there are some advice how to finish off those questions like that. I will show you after this part. Okay, maybe any questions first? Any questions? Easy, right? Easy, right? Easy, right? Helpful, right? I'm not sure who are designing this. Maybe I heard from Singaporean professor, but I'm not sure. Or maybe Indian professor, I'm not sure. Either from Singapore or India. But I think some Taiwanese professors, they use this, like, I believe some of you know this before, right? Right? Who knows this before? You know? You know? Okay. Yeah. But maybe based on what you learned before, do you know that this is coming from this? Sometimes students, they just learn, like, they enter cram school, and then, oh, this is blue, and they learn like a shortcut, oh, then they know, oh. But they don't know like how we get this. But this is getting from all these like cycles, and then we put into our a good arrangement to design the method. Okay.
Okay, let me give you another example. So another example is e to the x sine x dx. I think this example also in the textbook. I forgot. But check first. Maybe first you can try, but
If you see like the trigonometry, sine, cosine, the e is always c. So how does this work? Still, you can use the previous method, but you need to use it very, very clear. Okay, now both of these components, e and sine, they are cycling, right? E always e, and sine can be cosine, sine, cosine, sine, cosine. Right?
so anyway, let me just use our conventional way to state the u and dv. So let's say we have u is e to the x, and dv is sine x dx. And let's say this is going to be, I think either way, u and dv, you choose like maybe e for the integration or sine for the derivative. They will be, I think it's very similar, right? So I would just choose this way. Then we have this, and v will be negative cosine x, right? So we have negative e to the x, and then cosine x, okay? And then plus we have, this is negative from those, right? So negative negative become plus, so e to the x cosine x dx. Now we have another by parts here, right? And then do the same thing. And pretty similar. The difference in on the integration, we have sine x now. And then we have this become ex sine x minus v du, right? V du minus. So we have another one, right? We have another one that need to be solved. And if you continue using this by part, there will be no end, right? So we need to find how we can end. Well, actually, if you think clearly, the structure, the question, and this one is the same. So how about we just move here and later divide by 2, right? Okay, that's how you solve it. Or if we try using the previous one that we discussed, like taking d and I, this will be e to the x, and then this will be sine x. So this will be e to the x, this will be negative cosine x. And then how we end this di, okay? And then this e to the x, and this is negative sine x. Like if you continue, there will be no end as well. But look at the structure. The way we see our question is ex sine x. When we use the di, we are going to get ex sine x at this end. So I will just end up until here, which means that I will expecting this. So multiply all this and also the last one here, which we can write the question and then equal, this will be negative ex cosine x plus ex sine x, and then minus ex sine x dx. Precisely the same as we did before. Okay, and then this part I will move to here. So we are going to have 2 equal negative ex cosine x plus ex sine x. Now we take this and then divide all the formula by 2. So half. Let me write ex sine x first, and then negative, or maybe ex can be factorized. And don't forget, although it's not explicitly verified that we have will be a constant, there will be a constant, okay, at the end. You don't forget just the plus c at the very end. So we can also get this, okay, as our solution. Okay. Now I would like to give you one more, maybe one more example. So how about if we have like integration of tangent inverse x dx?
If we derive, we know that it will be 1 over 1 plus x squared. But if we integrate, another problem. Another problem. But we can deal with this with integration by part. Okay. Try. You can think like which part is easier to be, like, of course that if we try to find which one is b and I, of course tangent inverse can be integrated directly, right? So that will be the d. Okay. I have like a set problem, like I think 100 questions on integral. And Maybe I will check again. Okay, if our course will be covering all that integration. So sometimes I took some question from that setup. Okay. Like usually, do you know integration integration B? B as a B and it's like a competition for integral in MIT. Watch YouTube, find integral competition B or integral B competition. And they are, I think, sometimes like the question is like really difficult, but they can answer it like in like less than 1 minute, less than 1 minute. It's like crazy, really crazy. Maybe I can show you the link later. I will check again. Like they are just, I think just finished the competition. Like every year they compete like in a class, like they will like the competition like tournament. Like they will have like a champion at the end. Like all the nerds, kids, and students.
Interesting. Okay, now the tangent inverse. As I said, we can take the tangent inverse as our derivative. So we are expecting to derive, right? So we expect, let me just write with this, okay, to get the result directly. We get this will be that. And I think I don't want to make myself like more trouble. So I will just stop here and then just add this and multiply, and then and basically this is just integration by parts as usual method, right? So we can write this as x tangent inverse x, and then minus the integration x over 1 plus x squared, and somehow this one we can easily integrate, right? We can use substitutions. So take the substitution u so this will be 1 over 2 multiply with 1 over u and integrate. This will be ln. So we are expecting to have the half ln 1 plus x squared, right? This part, okay? So the answer will be minus half ln 1 plus x squared plus c.
So sometimes the integration by parts will give you maybe only half parts, right? The rest of it we need to integrate with another method.
If you still prefer the u dv, this is like you can choose u is tangent inverse x and dv is dx. Okay. So du is 1 over 1 plus x squared and b is x. Okay, last part before I end the lecture and I give some feedback question at the end. I would like to give you, so if the secant squared x dx, if we integrate this, this will be tangent, right? With the interesting one, if you have the secant x dx and the secant cube x dx, we are going to
continue this later. Okay? Like the secant squared, easily we can get tangent. But for secant and secant cube, we need to have a different approach. Well, for the secant cube, we need to know this first, and then we can move on.
Okay, any questions?
Any questions? Okay. I think our class is a little bit empty over there. Usually a lot of students. I think they maybe, I don't know
Where they are? Okay, that's okay. Okay, I will change the slide into this. Okay, wait. You can use the QR if you want.
Or you can go to the website. If you have any difficulty joining this quiz, let me know. If the QR not working, go to the website. I prepared maybe 3 questions. I hope 3 or 4. I hope the time is okay. The total time, I think around, I give you like 10 or 11. Okay. Yeah, around 10, 11 or 12 minutes. But each one, I think around 3 minutes or 5, 3 or 5.